So in 5 we have log base 4 of the cube root of 8a to the 6th b to the 3rd over c b minus 1. That's it. Okay, so first I have to eliminate that cube root. So power, the cube root is power 1/3, so I put 1/3 in front. Okay, now I see 3 factors at the top and 2 factors in the denominator, which means 3 factors will have plus in front, 2 factors will have minus in front. And all of them will get eventually that 1/3 distributed to them. So this is log base 4 of 8 plus log base 4 of a to the 6th plus log base 4 of b to the 3rd, but minus log base 4 of c and minus log base 4 of b minus 1. Many of you put plus in front of log base b minus 1, which it's incorrect because those factors come from the denominator. They have to have minus in front. If you by mistake put this plus, then b minus 1 comes from the top, but that's not the case. If it has minus in front, it comes from the denominator, or if it's in the denominator, it must have minus in front. So you cannot simplify this, don't even try, but we will have to put 6 in front, 3 in front, and then distribute 1/3 to all. So this will be 1/3 log base 4 of 8 plus 6 divided by 3, which is 2, log base 4 of a plus 3 over 3, which is 1, log base 4 of b minus 1/3 log base 4 of c minus 1/3 log base 4 of b minus 1. And this is it. We can't do anything else here. And that was number 5. Is number 5 okay? Okay, we want to look at number 6. Number 6 is 3 log x minus 1 minus 4 log x minus log 7. And first, of course, we have to remove those powers in front. So this is log x minus 1 to the 3rd minus log x to the 4th minus log 7. By the principle that we just mentioned a minute ago, those ones with a negative in front have to come from the denominator or go back to the denominator. It doesn't matter how you want to consider that. So log x minus 1 to the 3rd over x to the 4th times 7. It's not over x to the 4th over 7. I'm not saying it's incorrect, but it's not fully simplified. So we've done this in class, and I said, let's try to understand this shortcut. If it has minus in front, it has to come from the denominator. If it has plus in front, it has to come from the numerator, and vice versa. If it's in the numerator, it will have plus. If it's in the denominator, it will have minus. If it's in the denominator, it will have minus. And then you don't have to worry about anything else. So we said 5, 6, and 8, or 5, 6, 7, and 8. I'm not
5,
sure.
6, and 8.
And 8. Good. Any
Yeah,
questions on this? Any questions on this? So now let's look at 8. So log base 2 of x minus 1 minus log base 2 of x plus 3 equals log base 2 of 1 over x. We had an identical problem right before the test. That's why I post everything in the hope that at least a few of you will look. So first I have to, that's me. On this part is just me. I prefer domain. You understand that 1 over x to be greater than 0, that must be that x has to be greater than 0. In that case, when you intersect x greater than 1, x greater than -3, and x greater than 0, you realize that the common domain has to be greater than 1. Common domain, 1 to infinity. If whatever we get is not or are not numbers greater than 1, then we'll have to disregard them. So I condense now. I state the domain on the raw equation. Now I'm ready to condense. Ready? So the left-hand side is log base 2 of x minus 1 over x plus 3. And the right-hand side is log base 2 of 1 over x. So now we don't cross out, we don't simplify anything. All we have to do is just think in terms of a one-to-one property of this function, log. Two logs are equal, and they have the same base. These two must equal each other. There's no other way. So then x minus 1 over x plus 3 must equal 1 over x. And this is the proportion. We will cross multiply. X squared minus x equals x plus 3, and move everything to one side because this is quadratic. Always remember quadratic equations, depending on the format though, but in this situation I have to have 0 on one side. So I can factor completely, and that would be x minus 3 and x plus 1. So then x equals 3 and x equals negative 1. And you can say not so fast because you determine the domain. It's a common domain, 1 to infinity. So I will say yes for this, and I will say no for this one. It's not a number greater than negative 1. Forgive me, greater than 1. So therefore it cannot be accepted. Or you say, I don't care to present the domain. Fine. But in that case, when you get this, you have to go back and check and say yay or nay. Yes, of course. Number 12. You mean the Gauss-Jordan?
Yeah.
Okay. So we can, do you want to do it step by step?
Yeah.
Okay. Okay. So we have 3x plus y plus 2z equals 31, and x plus y plus 2z equals 19, and x plus 3y plus 2z equals 25. Okay. I already see that it's wise to already swap these two. So I have 1, 1, 2, 19, and 3, 1, 2, 31, and 1, 3, 2, 25. It saves me some time because I don't want anything else but 1 in the upper left corner. First row, first column. We call this x11. First row, first column. Okay, so now obviously I have to use row 1, multiply by something and add it to row 2, and vice versa, and the same with row 3. Obviously, this must be a negative 3, and this must be a negative 1. I have no idea why I'm losing my voice, but I am. Now for the next 5 minutes, we'll learn sign language. No, I can't teach you. I don't know anything in sign language, not one bit. But maybe I should learn. Okay. I copy the first row because this is the one that I do not change, or does not change right now. 1 times negative 3 plus 3. 1 times negative 3 plus 1. Negative 6 plus 2. And negative 57 plus 31, negative 26. 1 times negative 1 plus 1. 1 times negative 1 plus 3. 2 times negative 2 plus 2. Negative 19 plus 25, 6. Is this okay? Okay, next step. Obviously, I want a 1 here. So I will divide row 2 by negative 2. And I get 1, 1, 2, 19, 0, 1, 2, 13, 0, 2, 0, 6. I got the 1. I will multiply row 2 now and add it to row 1, and row 2 and add it to row 3. So for row 1, I need -1, and for row 3, I need -2. Okay. So I copy 0, 1, 2, 13, and if I destroy this column, then I'm going backwards. Okay. 1 times -1 plus 1, 2 times -1 plus 2, -13 plus 9, -2 plus 2, -2, -4, -26 plus 6, -20. So now we accomplished all this. Now I'm here. All I need to do at this point is divide row 3 by -4. I copy everything else. Finally, I just need to get rid of that. Multiplying row 3 by -2. And adding it only to row 2. And that will be final. So it's 1, 0, 0, 6, 0, 0, 1, 5, 0, 1. 1 times -2 plus 2. 5 times -2 plus 3. I'm sorry, plus 13, 3. So 6, 3, 5. And I have to go back and check. Is this okay? Have we found the error?
Yeah, I mixed up the numbers when I was multiplying them.
It's very possible.
Yeah.
Very easy to make an error here. Good. So anything else? As I said, I posted solutions. Is this clear? It's a circle and a line. Yes? Okay. The nonlinear system. Any questions on the nonlinear system? Here I was hoping only one student, I think, or maybe two, only one of you wrote that it's a horizontal asymptote. But yes, many of you said, as time goes by, so I gave full credit for that. But I was also hoping for the horizontal asymptote because that's what it is. Okay, this page is fine. Here you only had to plug in f of 0, 1, 4, and 52. This was not a trivial equation, right? So we had to replace by 30, you had to subtract, we had to divide, we had to apply natural log to get this. This we just did, this we just did, this we just did, and this is the exponential. Any questions on this page? Yes? Okay, this was a graph using transformations and finding the x and y intercepts. Here was just plug it in, and this was the better option. We had this in class. And let's see what else is here. We just did that. Yes.
On 2.
On 2.
I did it on my calculator, and I don't know what I'm plugging it from.
Let's take a look. So let's plug in any number.
Yep. No times 0. I put 0.2.
Okay.
That's it.
Yeah, so be careful. If it's 2%, it's 0.0. If it's 20%, it's 0.2.
Okay.
Yeah. Okay, so that was okay. This was okay. Okay, and the last, was just finding the first 4 terms of the sequence and then simplifying factorials. And this one was the same equation with the previous problem. Okay, so now let's take a look and let's go back to a problem, to a test 1 and test test 1 and test 2. Ready? Okay, whichever version you prefer, but let's browse and say we need more of this or more of that. So one more time, the final exam is a week from Wednesday, and I will be in this room from noon. Please do not miss the final exam, please. Okay, so here we had the rational equations, quadratic equations, completing the square, linear inequalities, absolute value inequalities, reading from a graph, finding the length and the width of a rectangular piece of plot, I believe it is. Find relative max, relative min, identify whether it's symmetric or not, piecewise defined function, graphing a piecewise defined function, find the equation of a line passing through 2 points, find the rate of change of a function between 2 points, graphing using x and y intercepts, solving equations, radical, polynomial, and quadratic in form, and then find the equation of a line passing through a point and perpendicular to the line. So what do we continue with? I would like to finish all these topics today and Wednesday in preparation for next week. So what would you like to continue with? Let me go back.
Maybe we're doing the first 3.
So we have equations, rational, quadratic, and quadratic by completing the square.
Rational.
Okay, so let's start with the rational then. You have another in mind, or you want to work on this particular one? Okay, do you have one? Can you make one? You want to make one up, or? Because now it doesn't matter. It doesn't have to be factorable because now we know the quadratic formula. So at the end of the day, we may not be able to factor it, but we can still find the solutions. In real life situations, that's what we will encounter. Or we can look at the other version, because I had 2 versions of this.
I have a question for the second version when we get to it.
Yeah, let's start with that.
When we get to it, though, because you're on right now for more.
Yeah, is there a rational equation?
No, mine's for a different question.
Yeah, but give me the rational equation and then we'll answer your question.
You mean for the first? Well, no, mine's for a different topic.
I know, but just give me the rational equation from that version and then we'll answer your question
Okay.
next.
The equation is x plus 5 over x minus 2 equals 5 over x plus 2 plus 28 over x squared minus 4.
Perfect. So here's a rational equation, and we would like to, so that you're next with your question. Okay. So this is a rational equation. I recommend this method, but if you, yes.
Were you recording?
Yes. Thank you. Yes. I am. I looked.
Thank God you're here tomorrow.
Every now and
forgetting.
Yeah, every now and then I look just to make sure. Yeah. Thank you. Okay, so first I will move everything to one side. This is the method that I suggest. There are many shortcuts and many other methods. If you prefer other methods, I'm fine. Okay, so x minus 2 minus 5 over x plus 2 minus 28 over x plus 2, x minus 2 equals 0. And I will write that x cannot be plus or minus 2. We know no denominator can be 0, so that will not be acceptable. A fraction would be undefined. Now I find the least common denominator. And the least common denominator is just the product of those two. But if you forget the equal symbol and 0, you're not solving. You're changing the equation into an expression, and you're not going to find x. So please carefully remember that. So x plus 2 and x minus 2. And we know the adjustments. This one has x minus 2, but the product is the least common denominator. So therefore, we multiply the denominator by x plus 2. We have to multiply the numerator by the same thing. For x plus 2, we need an x minus 2. And here you don't even need to write anything. Since I put a reminder for both the first two, I say, okay, I'm going to put a reminder, but it's just one. So now, remember what happens. So I have to distribute x plus 5 or FOIL these two, x squared, 2x, 5x, and 10. So this is x squared plus 2x plus 5x plus 10. This is this. The next step is easier because I only distribute negative 5. So I get negative 5x and plus 10. The third step is easy also because all I have is negative 28. Do we remember doing this? See, that's why I always try with all my classes to review and review and review. We don't review. Chances are that we may not remember. Okay, so then combine like terms at the top. I see that these two go away. I see that there is an x squared. I see a positive 2x, and I see a negative 8. So here's a shortcut. Yes, you can write it over 1 and then cross multiply. Or, even easier now, since we know what happens, when is a fraction 0? Not when the bottom is 0 for sure, but only when the numerator is 0. So then the numerator must be 0. Or you say, no, I want to write over 1. I want to write the fraction again, the proportion, and then cross multiply. It's fine. Same thing. And now I see x plus 4 and x minus 2. And immediately I get x equals negative 4 and x equals 2. But like with log equations, I stated the domain from the very beginning. With log equations, I state a domain. And I go back and say, hey, whoops, no, negative 1 is not greater than 1. It cannot be accepted. The same thing here. I stated the domain from the very beginning. And I can't accept x equals 2. I will write yes next to this one and no next to this one. Or you say, I don't like the domain or stating the domain, but I promise to check. You have to choose one or the other. For me, it's easier to go back and say, oh, okay, it cannot be that. Then go back and plug it in. Is this better? Yes? Okay, Garrett, you're next.
I had the test version too. I was good the one. I'm gonna just give you the problem.
Yes.
Okay. It's about the length and width.
Okay.
Top one.
Okay. So we have the length is 10 feet longer than the width. The length is 10 feet longer than the width. If the area is 24 square feet, find the dimensions. So the area of this rectangular plot or whatever it is must be length times width. So this side will be replaced by x times x plus 10. The other side is 24. I know that after I distribute and move 24, I know that this is a quadratic equation, so I have to set it equal to 0. So this is x squared plus 10x minus 24 equals 0. And I try to factor. And I see an x plus 6 and an x minus 4. No, I see an x plus 12 and an x minus 2. Daydreaming, sorry. So then x equals negative 12, which will be crossed out. It cannot be negative 12 feet. So then x equals 2, and it is in feet. So if x equals 2, then the length must be 12. So it's a 12 by 2. The area is 24. I have to go back and check because I created an equation, right? So indeed, 2 times 12 is 24. Is this okay?
So I got the same answer, just a weird problem. Yeah, I got the same answer, but the way I solved it was wrong, was weird.
Okay. But is it clear now?
Yeah.
Okay,
yeah.
perfect.
I just did a weird, complicated steps to solve it.
Okay, so this was our rational equation. Let's see what is next. What we are going to do with this one. Can anyone give us the first step?
Divide by 3.
Absolutely, I have to clean it up. Excellent. And then
Take
take the square root. Divide both sides by 3 first and then take the square root. Excellent. But it doesn't mean that if you want to see it, we cannot solve it. So you tell me. I just want to browse through everything and we'll come back.
Can
Okay.
we do this? Can we do the completing the square
Yes, of
problem?
course. Yes. So let's do the completing the square. So it's x squared minus 8x plus 10. Good. So remember the steps. The polynomial has to be in descending order, first of all. Is it?
Yes.
Good. What is the middle coefficient? -8 divided by 2.
-4,
-4 squared.
16.
That's it. And at the same time, I will move 10. So then we have x squared minus 8x plus 16 equals 16 minus 10, which is 6. Now the left-hand side has to be changed into a perfect square, which is very good. And yes, we're back to taking square roots. So this x minus 4 equals plus or minus. Do not forget the plus or minus. You will not get 2 solutions. It's quadratic. I have to get 2 solutions. X equals 4 plus or minus the square root of 6. Questions on this one?
So the middle
Yes.
term, it's you divide by 2 first, and then square that answer
Yes.
to get that, and then whatever you get, you add to both sides.
You have
of
to,
the equation.
yes, yes. Well, what we normally do is we add and subtract. So this is the idea. X squared minus 8x plus 10 equals 0.
Mhm.
I can do this. Why? I'm adding 0. Nobody cares.
Yeah.
I'm not changing anything. But these will be together, these two will be together and move to the other side as 6. That's what we really do. Where, in other words, I'm giving you $5 when I get it back, so no deal. I'm adding 16 and subtracting 16. Or, easier to say, I'm subtracting 16 onto both sides, because if I add and subtract, this is negative, and when I move it to the other side, it's positive. So it's the same thing as saying I'm adding 16 to both sides, or if it's easier for you to remember, I add 16 and subtract 16, no deal. But I group it differently.
Correct.
I still have 0 in there, but the 16 goes with the first 2, and the other 16, the -1, goes with the other term to the other side. But that's exactly what we really do. Or you say I add to both sides, which is the same thing. Okay, inequalities, linear inequality, absolute value inequality. Absolute value, very good. So we have 3 minus x over 3 in absolute value, minus 1 less than or equal to 3. Remember, you cannot break the absolute value. You cannot add, you cannot subtract, you cannot put anything in. There are 2 properties, but we don't discuss them in this class. So all we have to do, or can do here, is, first of all, clean it up.
Add 1.
Add 1.
Very good. So I have 3 minus x over 3 less than or equal to 4. And remember, if it's less than or equal to, we are looking at in between. If it's greater than or equal to, we are looking at outside. So because it's less than or equal to, we are looking at in between. In between, because the absolute value is less than or equal to a number. There are only two options, either in between or the outside. But this one is in between. I have to subtract 3 from all three sides.
-7.
Yes,
Um,
-7 less than or equal to -x over 3 less than or equal to 1. And now I have to get rid of -1/3, multiplying everything by -3. What do I get here?
21.
Yes, what do I get here?
X.
What do I get here?
-3.
Good. However, this will not make any sense if I would keep the same inequality symbol.
You gotta switch and put your multiplying by a negative.
Right. It will not make any sense. I'm telling you that x is a number that is greater than 21, but at the same time less than -3. How can a number be greater than 21, but at the same time less than -3? If it's positive, it cannot be less than -3, right? So that's why we have to do this. And now please read it from the right. -3 less than or equal to x less than or equal to 21, so you can correctly identify the interval
And it's bracket because it's
of
an
the
equal
equal
to.
symbol. Yes. Yes.
But that's your final answer. is
That's the final answer. I like it. I'd like to write x in, but since there are no parentheses here, it cannot be confused with an ordered pair. And of course, that's not mandatory. This is what I think we should write. But
I've never seen somebody do that X in part.
yeah, actually the mathematical symbol is this. Or this, for this. This belongs to, is inside, but there is no need for that symbol. I just use this plain in.
Gotcha.
Okay. Reading from a graph, can we determine the domain and range and find the max, min, increasing, decreasing? Find f of 2 or find x such that f of x is 5. Do we have any difficulties with that? Okay, we just did this problem. Relative max, relative min. The relative max is a positive 3, and it's when x is -3. And relative min is at -4 and -2, and the relative min is -1. Yes, this is symmetric because as you see, -3, 3, 3, 3. -1, comma 0, 1, comma 0, and 0, comma 1. Symmetric with respect to the y-axis. It's an even function. Okay, I think we should do this, or one like it. Can we do this? Okay. So we have f of x equals 2x minus 4 for x less than 1. And x squared plus 2 for x greater than or equal to 1. So please remember when we are asked to graph such a function, we should immediately look at domain first, right? I don't care for this notation. I care for this notation. I don't care for this notation, but I care for this. And now it's very clear that everything is there, so I have all real numbers. But the key x value is 1. 0 first and 1 to the left parenthesis, to the right a bracket. This is extremely important because it will tell me which one is an open point and which one is a full point. So 1 comma whatever will be an open point, and 1 comma whatever here will be a full point. So I even take notes and say to the left of 1, okay, 2x minus 4. And to the right of 1, okay, it's x squared plus 2. Now, forget about everything here, and let's just talk about x squared plus 2 for a moment. We've graphed this function millions of times. It's x squared up 2, right? Okay, so keep that in mind for a second. Good, so I plug in some numbers. Okay, I'm going to plug in 0, I get -4. I'm going to plug in 1, and I get -2. And you should say you can't. You can't plug in 1 here. True. That's why this will be an open point, because I can't plug it in. And when I plug in 1 on this side, I get 3, and when I plug in 2 on this side, I get 6. That's all I need to graph this. So from left to right, first point is 0, -4. Okay. Full point. And then 1, -2 is an open point, and I connect. If I extend this line, that will be a terrible mistake, because this line has to show only between -infinity and 1. And it only shows between -infinity and 1. It cannot show to the right of 1. Okay, now on the other side, I have 1, 3. Because of the bracket, I have a full point. And 2, 6, it's right here. Remember what I just said. This is the graph. But I won't dare to graph that, because this graph is only from 1 to the right. So I can only copy this. Nothing else. If I were to copy the whole thing or graph the whole thing, this is no longer a function by the vertical line test. If I were to copy the whole thing. So 1 is the threshold. To the left I have a function, to the right I have a different function. And now I can identify the range, which, by the way, is not really friendly. So it goes from -infinity to -2, and then from 3 to infinity. So -infinity, -2 with a parenthesis, and 3 union 3 to infinity. I don't really need the graph for the range. I see it here. But it's safer to look at the graph as well. Any questions on this? You should feel much better, because we had a lot of experience now, and now we are just reviewing. Better? Yes? Okay, so let's continue. Find the equation of a line passing through 2 points. We find the slope, and then y minus y1 equals the slope times x minus x1. Do we need to see this?
Yes.
Perfect. So we have 2 points. Two, -5 and 1, 6. We're asked to find the equation and solve for y. So these are 2 points. It's a line, so I have to find the slope 6 minus -5 over 1 minus 2, 11 over -1, which is -11. So y2 minus y1 over x2 minus x1. And then y minus y1 equals the slope times x minus x1, because none of these is 0, b. If one of them were 0, a number, then I would have used y equals mx plus b. I put in all the numbers. It doesn't matter which ordered pair you want to use. Let's say I'm going to use 1, 6 and -11. It doesn't matter. You will get the same equation with the one that I'm going to get. So if you use the other point, -11 x minus 1, -11 x plus 11, and then plus 6. So then y equals -11 x plus 17. And that is the equation of the line passing through the given point.